Okay, so this is the third part, or third chapter, talking about Microsoft Access. We're going to be focused on how do we get data out of the database. Right? So the value. I mean, why do we have databases? The value associated with a database is really the ability to be able to turn data into information, capture information, organize it, analyze it, turn it into knowledge. So basically, it's the value proposition is getting answers to questions, right? And the answer is hidden in the database. So the trick is being able to extract that. It's not necessarily readily apparent. So, but what the databases give us the ability to do is to you know organize it, manipulate it, and be able to, and ultimately be able to identify um, knowledge or information, which is then moves up into knowledge. So this idea of a query. So we talked about databases before. We talked about you're creating rules, you're doing all this work, you're loading data. Well, that's the first part. All right. So that's important to do. But the other important thing about a database is you want to be able to get the data out. All right. You want to be able to get you want to be able to get information out of the database. All right. So there's an I there's a technique which is built into the relational model, Codd's original relational model around querying a database. So basically, what it is, it's a computer language specifically designed to uh, ask a question to get an answer. Right. So how you create a query in Access, uh, by starting off, you can identify whether you want to do it on a single table or you can do it on multiple tables that are joined together. All right, we'll look at that. But right now, simplest case will be doing it on a single table. You then add fields to the query, like what fields do you want to extract from the query. You can then run it, and then finally, at the end, when you're done, you can save it for future use. All right. So this is, and we'll see how this shows. There's a couple different techniques which have been developed around Access. Um, Access actually has adopted something called QBE. Query design is based on a model called QBE, query by example. All right. Which basically you kind of draw a picture of what you want the query to look like, and then and then it can be executed. There's also in a lot of cases, like with programs, if you're doing your stuff programmatically, you can use SQL commands. So what you'll see is actually look like in programming, and you'll see that that's very common in most applications. You'll see a series of SQL commands in which data will be extracted, brought back to the program, which will then be processed. Right. So the structure of a query, if you look at it, you have the table up top. So this is like a joint, is an area where we can have one or many tables, and define what the connections are between the tables, right? And below that, we have this grid. Okay, now the grid is really the where we basically select what fields we want to see, for which fields we want to process, the table they're from, whether or not we want to sort anything into sequence, maybe sort ascending or descending, or the result set, whether we want to display the results. So if you see this clicked, you will display the results when it comes back. If you don't, it'll still process it, but it will not display it. And then something called the criteria, all right, where basically you can put selection criteria, what you want to look at. So in this case, explaining this query, this is a very simple query here. We want to take out of this table right here, out of the client table, we want to take three fields: last name, first name, and state. Mm, We're going to sort it on. We're going to sort it on the last name, and then, and if we just did that without any qualifier, if we take this criteria off, we would retrieve every row in the table. All right, we retrieve the last name, first name, and the state from every row in the table. If we qualify with the criteria, what will happen is if you put, like, for example, an equal sign equals PA, what it will do is it'll only bring back those rows from the table that have a PA in the state field. All right, so this criteria becomes very important because the criteria is really the mechanism by which you can set the rules for identifying what you want to extract from the data. All right, so as we say it here, provide criteria for records to be that must be met in order for the table for the results to be displayed or to be able to select those out of that table. So so a query can be run, and basically what it will bring back is something that looks like a table, another table actually, but they call it the result set. All right, but it looks like a table. All right, it'll be in the form you specify down here. So if you see, this is the results of that: last name, first name, state, all the states, all the names, ordered by address, or excuse me, by last name. Talked about criteria. For the comparison operators, you can do a less than, a greater than, an equal to. You can also do a equal to, a less than, or equal to. All right, now the way that works is, and actually, this is actually an important concept to grasp because what will happen is if you say less than 5, the result set of that is 4, 5, 3, 2, 1, 0, and anything it's negative. All right. If I say something is less than or equal to 5, it would be 5, 4, 3, 2, 1, 0, and anything negative. All right. So basically, if you say it's equal to, less than equal to, it would be that number plus everything behind it. So when you're looking at a query, you want to make sure you see the difference between whether something is less than or less than equal to, right? Or these other ones. Other things we can do if you have two a greater than, less than sign, that means not equal to. So if you're looking for everything, it does not have a 0 in it. You use that as the qualifier. A between can be used to identify a range, something within a range. So if something is between 10 and 20. All right, so that would be 11, 12, 13, 14, 15, so on and so forth. In is something you provide a list of values and you see if it matches something in that list. So this would be looking for something in a field, any field that would have a 1, a 5, or a 10 would match that criteria. And then the last thing is what we call like. So like is a pattern matching. So if I say like C blank blank, what that would say is that would say give us everything that begins with the letter C and has 2 letters after it. All right. If I did like C star, it would be give us everything that begins with the letter C. All right. If I do a star C, the opposite of that, I'll get everything that is that ends with the letter C. And finally, if I do a star C star, I will get everything that has a C contained somewhere in the string. All right. So that's what this like is. So this is actually a very powerful tool to be able to analyze data and work with data. So query wildcards. So this is what we call wildcards. So match character in a specific position, match any number of characters. So like you see, as we see here, question mark. Okay, what that says is the pattern should be C followed by 2 characters. All right. C star, as we said, will match any number of characters. So basically, it's anything that begins with C. And then a pound sign is match any numeric digit. So one of the big concepts that we try to work with in terms of doing queries is questions of ands and ors. All right. So what happens is you're not limited to having only a single criteria. You can actually put multiple criteria. So you can actually have different combinations of different criteria in order to do a select of data. In addition, you can either use an and or an or. All right. So and is basically is kind of targeted, limiting number of records. Or is more inclusive. So actually, you would use OR for creating multiple um, sets uh, of queries. So this is an AND. So if you look at this, the way you would read an AND, it would be everything on the same line. Okay, so criteria here would be this and this and this. It would match. It would have to match all three or match both in order to be selected. If it matched one, doesn't meet the criteria. Okay, so that's the and. The or. Oh, and you can do as many of ands as you want, as many ands as you got columns in your that you're going to be extracting. All right, and or is you can match multiple sets of criteria. So each line we see under criteria can be considered a set. All right. So this and this and this and this. If you go the next line down, under where it says or, you can also put more selection criteria, but it will match for all of the criteria on this line. And if it finds it, it will select it. If not, it'll go to the next line and it will match everything on that line. But the two lines are totally independent of each other, right? The two sets are totally independent. So if you have something here, it has to match every value on the criteria, match all of the ands before it goes to the or, the next set, and then would have to match all that, or ultimately it would not match, right? So some examples here, some compound. So this is going to be if you see everything both on the same line, give us everything that would begin with the letter B and would be in Pennsylvania. All right. So you would get everything would be Pennsylvania and it would begin with B. Now, in this case, be everything that begins with Pennsylvania or anything that begins with the letter B. All right, so this could be, you would get everything that's in Pennsylvania, but you'll get any city, no matter what the state is, with the B. Every, any, I'm trying to think of Baltimore, so Baltimore and Bethlehem, one's in Pennsylvania and one's in Maryland. Baltimore and Bethlehem would both be selected, would both match on this criteria. And obviously, PA is the only one that would match in this criteria. All right. Parameter query, there's functional capability inside of Access that'll let you set up an application where you feed it a parameter. It'll take a parameter and it'll put it into the query and be able to pull things up. So it's really useful for doing, say, doing analysis and things like that. We're writing an application where you could be doing lookups of data. And you have different kinds of calculation. So you could do max, you could do left, find the number of characters in it, in strings, finds, rounds the value, finds the largest value, counts the number of characters, returns the year from a date time. So you got a bunch of different functions, and we'll see these in action downstream. Summary query. So summary query is, what will happen is a return set will give you everything that matches that table. So if you get 1,000,000 rows and you have 100,000 that match, you get 100,000 rows back. Right now, you might not necessarily be able to process. 100 rows of detailed information is probably not as useful as you would like it to be. So there's an option. There's what we call the summary, a sum. All right, or what they call group by. We'll go more into this later, but basically it works as a query. It looks like a regular query, but what it'll do is it'll take the result set and then it'll summarize it by however you set the value. So you can find all of the. So you would have the ability to add everything up, add all the values up, summarize and get counts and things of that nature. So you do average, you do count, you do max and min, you can do some. So this is. So this is actually pretty useful. This is actually, we'll see this because really one of the exercises we'll be doing, especially with Sam's Club, is going to be shrinking that sucker down from, its current size into, a working set of summarized information. And that is it for queries.